Hello, everyone. This is Amanda Cavallaro from GDG Cloud London. I'd like to hear from you in the chat, wherever you're speaking from. Let us know who you are, where you're talking from today. It's been a very busy month for us at GDG Cloud London. We've had a handful of events. Some of them were talks, other workshops. We have another talk coming up on the 6th of April. I'm going to share the link here in the comments with you for this coming up event. We also have some news about certifications coming up. We're very excited to share with you. And our speaker today is Bianca Ximenes. She is a Google Developers expert for machine learning, and we're very excited to have her today. She's running a few minutes late, so I'm going to chat with you until she gets here. So talking a little bit about the events that we are having this month, we have a very special event, which is close to my heart, so I'm biased to talk about it, but it's a month of learning about actions on Google. So we started on the 1st of March, and we've taken a training. So we had videos, code labs, live mentoring with 4 Google Developers experts. So it's been a very intense month. We're reaching the end. They also had the opportunity to share an idea of a conversational action that they would build. And now they're actually building these actions. And at the end of the month, we are going to have them presented. So there's going to be some prizes to give away. I see that Bianca is already here. I'm going to wait for her to share her presentation, and then I'm going to bring her up here. So you're still in time to join us for this Actions on Google initiative. We are on Discord. I'm also going to share the link with you. And if not, I will see you on the next general talks on the 6th. So Bianca is just sharing her presentation now. We're very excited to have her here. If you don't know, this is the second time we're having her here at GDG Cloud London. We actually reused the picture from her last talk here, so she made it very convenient for us. So we always love returning speakers, also first-time speakers. If you've never spoken at a conference before, at a meetup before, we're more than happy to help you out. So if you'd like to show your presentation to us, to present a chat or something, to come and have a chat with us to present a project, we're more than happy to take on first-time speakers as well. And not only about cloud. If you've known us from the time when meetups didn't used to be online, we were in person, we used to host events on a diverse set of topics. We had JavaScript courses, Firebase, React, Angular. We had so many amazing speakers and mentors with us. And they're still here in these initiatives that I told you we're going to have in the coming months. All these people that used to help us out in person are going to be here online with you. So I see that Bianca has shared her presentation. Bianca, I'm bringing you your video right now. Hello.
Hi. Hi, Amanda. How are you?
I am fab. How are you today?
I'm good. I'm good. I nearly didn't find the presentation, but now it's here. So
it's here. So where are you and what time is it there right now?
I'm in Recife, which is a city from northeastern Brazil. I live by the beach, very warm beach, very nice beach. It's 3:34 right now, so I think I'm 3 hours behind you. 3 hours behind.
That's it. That's amazing. Wow, living by the beach now would be a dream. Lucky you. So I'm going to bring her presentation now. I think, Bianca, you're sharing a black screen. It's to give us some, I don't know, sensation, to get to the point. We're looking forward to your presentation. Actually, it was our birthdays just these past days, so it's been an exciting month for us. Do you still have cake in your place?
Yes, but just a little bit left.
Same thing here.
Yeah.
Yeah, so I lost your presentation.
Yeah, I don't know.
And now I lost her. This is the amazing thing about hosting events online. You experience new sets of problems that, I mean, you had different problems on in-person meetups, but then these days you even lose your speakers and she's back.
I hope
What a
internet
journey.
helps us today. Yeah.
This is what we do with life. Even when everything is against us, we are resilient. We, make lemonades out of the lemons and the whole story. If there's
Exactly.
one thing I don't know is expressions in any languages. And I have her presentation, and
Okay,
I leave the
cool.
stage to her to present herself yet once again. And thank you for coming back to GDG Cloud London. The stage is yours.
Thank you for having me in such an important month, which is the women's a month we specially celebrate women, right? And it's also the month of our birthdays, so it's very special to me. And today I'm here to talk a little bit more about how to design human-centric AI applications. Just so you know a little bit more about me, I'm a machine learning GDE since 2019, but I've been in GDE program since 2017. I used to be a product GDE, but then it was discontinued. So now I'm a product alumni. But yeah, besides that, what I do is I'm a PhD candidate for ethical machine learning applications. And I'm also artificial intelligence program product manager for Gupy, which is the biggest HR tech in Brazil. We help people, candidates and enterprises connect and to form, I don't know how to say the mission in English, but it's like fair and charming careers for everyone. So that's our mission. And I'm here to talk a little bit more about the Google Guidebook, actually, the pair guidebook. But I'm not going to get ahead of myself. Let me just show you a little bit more about the pair guidebook. For those of you who don't know, PAIR is an acronym that stands for People and AI Research Team in Google, and they are part of the Google Design and the Google Brain um, departments. And a while ago, in early 2019, they launched this guidebook to help people make products that involve AI, database products, right? Where we use machine learning and deep learning and things like that. So we have essentially 6 basic chapters. I helped review the chapter on explainability and trust, but today we're not going to talk too much about that. Just so you have an idea, it goes like that. So it's kind of weird, but you count it like that, like the order of the chapters. And it's just 6 chapters. It's a quick read and it's very insightful. And I'm trying to bring today a little bit more about the highlights of the guidebook, right? So if you want to log in and take a look by yourself, you can leave feedback here and join pair.withgoogle.com just so you can download worksheets and get a lot of different materials to help you build more human-centric AI products. So the first thing I'm going to talk about, though, is a mental model. So if we go back here, right, mental model is chapter 3, but we don't have time to cover everything. I'm just going to cover a few things. And I want to start talking about mental models. So what is a mental model, right? I think all of us have heard about it at some point, but not often we know what it is. And I have this story to tell you. I was once in a very, very long time ago in the pre-COVID scenario, right? I was in a conference, in a presential live conference, and I went to the bathroom just before my talk because I always get very nervous. So I always need to go to the bathroom, even if it's just like to look at myself in the mirror and breathe, right? So I met this woman there. Her name is Leticia, or Leticia in Portuguese. And the thing is, I was in the cabin and I kept hearing someone saying, look underneath the mirror. It's underneath the mirror. Look underneath the mirror. It's there. No, look underneath the mirror. And I was like, what's going on? Like, what is it about the mirror, right? And then when I walked out, the thing is, I noticed that the hand dryer machine was not plugged there where it normally is, right? You have the cables, you have the outlet, you have everything, but you don't really have the machine itself. So then what people were doing, like the women in the bathroom were doing, was essentially they went there to dry their hands, and when they didn't see the machine, they just left with their hands wet. And Letitia got very, very she didn't like that. I think it was like, well, I'm doing my job. I'm putting paper towels there and they can use it. But people didn't see the paper towels. So she kept telling them that the paper towels were underneath the mirror. And I took the picture in a way where you can easily see the paper towels, right? But it wasn't like that. It wasn't like that when you actually were in the bathroom washing your hands. It was really hard to see because it was really underneath the mirror. And people are trying to make a quick fix, right? Put in like a label, paper towels, paper towels, paper towels. But the thing is, why did that happen, right? Why something like that happened? The thing is, when you are in the bathroom, like you go to the bathroom in a public place, it's very normal that you don't really think about what you're doing because you're very familiar with what you do in the bathroom. And you're really familiar with the flow of your activity. So you just go there, you do your business, and then you go and you wash your hands, and then you just leave, right? Like you dry your hands and leave. And you're not really thinking about it because you already have a mental model that tells you how things work, and you don't have to pay really close attention. So do you know sometimes when you do stuff and you don't really remember like how you did it? Like, oh, I got to work and I came driving, but I don't really remember like the route I took because it's just like second nature for us. We already have a mental model that takes care of all those things. And the thing is, when people remove the dryer here and put the paper towel underneath the mirror, which is a very common architectural decision nowadays, I think. Woo, sorry. The thing is that people got lost because the mental model broke. This type of difference, like this type of change in a scenario, breaks people's mental model. But then they end up finding themselves like when Letitia showed people where the paper towels were and they saw the letters and they saw the labels, people would be like, oh, I'm so stupid. So everybody in the bathroom would be like, oh, I'm so stupid. I'm so stupid. I didn't realize. I didn't see the sign. But the thing is, you don't capture information all the time. You only capture information when you're actually looking for it. So you are not looking for information considering where the paper towels are or where the dryer machine is when you're washing your hands in the bathroom. You just count on them to be in the same place they always have been. So they feel like they're stupid, but they're really not, right? So just for us to have an idea of a mental model in context, this is a good example, I mean, in the broad world, right? But if we were to see a mental model in context for AI applications, I have here two different face recognition algorithms, two different models, right? And I have the system Gamma and the Sigma system. And I have here those two different models that let me know who is in the picture. Like they're able to identify who are the people who are in the pictures. And in the year of 2018, I gave a lot of speeches and like talks throughout Brazil. And I asked everybody where I was like when I went to give talks, which is like for over 1,000 people. And I always ask them, which system seems more trustworthy to you, right? And like either Gustavo and Guilherme here, which is the name of those two guys, or the ones with all these other Oriental girls, which I can't really pronounce the name, so I'm not even gonna try. But I'd ask them, and it was really a talk about explainability and dilemmas in machine learning. And I expected people to say that this was more trustworthy because it tells me how confident the system is on about like its labeling. So I think this is Gustavo with 67.3% certainty. And here I'm not saying like how sure I am about Zhao. I'm not saying how sure I am that she really is this person I'm labeling. So I'd show that as an example of this system being more trustworthy. And actually, what the thing is, people usually say that the Sigma system seemed more trustworthy to them. And I'll be very, very like shocked and not understand why that happened. So I started like after getting repeatedly, let's say, swapped answers from what I expected as a person, as a researcher in AI. So then I started asking people why they thought that happened, right? And the thing is, we had our first break because what they did was they thought this system was more was more trustworthy because the system was able to identify different oriental faces, which are much harder to identify than pictures from people that live with us every day. Because obviously, Guilherme and Gustavo are very, very different. But all those other girls, they're very, very similar. And I thought that was concerning, was like a weird thing to think of, but I understand. Like we have a cognitive bias that helps us identify better people that are from the same ethnicity that we are. So we have a hard time, or at least a harder time, identifying people that are from different ethnicities than our own. And this is also true, like the other way around. Like people that are Oriental, they have more difficulty to tell apart Westerners, and this is something normal. But it's weird to think that the model would be the same way. So the first break that I considered was the thing of deterministic and probabilistic function, because what they were saying was, well, this model is the model is doing something much harder here, and it's doing it with 100% certainty. And I was like, why the model has 100% certainty, you think? And people would be like, oh, because it didn't say that it was only 67% sure. It just said who the person was. And I was like, yeah, it just said who the person was, but essentially it's not 100% sure, because no machine learning system is ever 100% sure of anything. And people would be like, wow, but I didn't realize that. I thought that they had to put like the Sigma system, the Gamma system, which was the first one, had to put the labels for the confidence ratio because it wasn't very sure about who the people were. And the other one was very sure. So the first break is the deterministic versus probabilistic aspect of the thing, right? Of the system. Because usually people are very accustomed to using things like that. Like when they approach technology, when we use our phones or when you use our computers or when we use a simple calculator, things don't change. Like what we do is always 100% what should happen, at least. Like when you put 2 plus 2, it won't say like, oh, we're 90% sure this is going to be 4, right? No, it's always 100% sure because we are used to working with the deterministic paradigm. And machine learning comes to change this a little bit because everything we do with machine learning is probabilistic. Everything has a chance of being right, or has a percentage of accuracy in a whole, in a validation data set. So it's not the same thing. So this is the first thing that happens to people when they start getting making a relationship with an AI-based product. So this is something that changes, and that we ought to let them know that what we're doing is taking a guess, a very well-educated guess, or 95% of the time accurate guess, but still we have the probability of being wrong. So this is always something that people need to know and need to learn, and that is not very natural to them. And the thing here is that we have this myth of the anthropomorphic intelligence, right? Like an intelligence that is just like our own. It's just like the model works just like my own brain works. And this is not the case, definitely. So there's this sentence, this quote I really like from the IEEE Ethically Aligned Design, which is a manual for ethical systems, ethical AI systems that are being designed and projected. But they say there lies a danger in uncritically attributing classical concepts of anthropomorphic autonomy to machines. We run the risk of assuming economic and political dimensions that do not exist. General and popular discourse may not share in the same nuanced understanding. So people have a lot of expectations about the system. People have a lot of expectations that since this is a system that usually when I make a relationship or when I work with anything related to technology, the technology is always 100% right. This system, even though it has to do with intelligence, which is something more less definitive or more fuzzy than traditional programming, I also have the same expectation from it. And I expect it to be always right. And I think this is a really great example, like of what people expect from machine learning systems nowadays. Like when you don't work with it every day, and you know that is not the case. But people see movies such as Ex Machina, which is a great movie, great entertainment, and really interesting things to discuss later and debate about. But what people expect is that this is what they are shown every day, is a machine that is capable of everything, is just like a human, is just like us. So it will not make a mistake. And because we humans make mistakes, but we do not like to admit that we make them, right? So we have this kind of different expectations from intelligent systems. But the thing is that artificial intelligence for now, and probably like for a long time still, is just a set of techniques that rely on mathematical optimization in broad scale and use tremendous computing power, right? So this is a much more accurate depiction of what artificial intelligence system really looks like. It's not really like that, right? But it's like, this is a good abstraction of how data is organized and how it has different weights and everything. So it's nothing like a person. It's nothing like, it doesn't have the common sense a person has, right? So people are still trying to get a grip and understand what is this thing and how does it work. And it has a lot of impact on how they deal with those systems. And the thing is that working with advanced maths and statistics is very hard, because you have to have this really profound notion of everything. But like the by person won't really know what you're talking about, right? They won't really be aware of those details and how, what is an F1 score, or what is a false negative and why is it important for the model, and what is a model anyway, you know? So it's really hard to work with that, because it can look very cool, but very quickly make the person not really interested anymore. So you have a lot of wow factor on one hand, but you also have like the constant menace of a meh factor when they realize that the thing doesn't really work as they expect. So when your system makes a mistake, the people won't be like, oh, I am so stupid, I didn't know how to use the system. They will be like, the system is so stupid. And your user will think that your system is stupid. It's not like the bathroom goers that their mental model was broken and they'll be like, oh, this is my fault, I was stupid. No, when your system breaks and they have this huge expectation of how it should work and how intelligent it should be, when it breaks, they're going to think like, this system is so stupid and I'm not going to use it anyway. So, well, maybe this is too abstract. So let's like have an example, right? I don't know if you know this type of app, but my dad uses it all the time because he's really into gardening, especially now in COVID. Like he spends a lot of time in his garden and doing things to automatize his home. But the thing is, this app identifies flowers, plants, and trees when you take a picture, right? This is just one example. It's not even the one that my dad uses, but I didn't find a good picture of it to show. But essentially, that's what this app does. And it uses deep learning to identify what it is that you have in the image. So how does it happen, right? Like how the system works, like how is the common flow? You point to anything, like not anything, like you point to a flower or a plant or something like that, and you take a picture. And the system's gonna let you know, for instance, well, it's an orchid. I don't know if this is an orchid. I'm really bad with flowers, but like let's suppose that this is an orchid, right? And you're gonna be like, well, this is an wow factor. No, because let's say that this is not an orchid. This was a daisy, and the system was supposed to know that this was a daisy. This was not an orchid. So you're gonna be like, oh my gosh, of course this is a daisy. And then you're gonna be, meh, the system's not good at all. The system is so stupid. Like it was supposed to be an expert or really intelligent about those things, and it really wasn't. So I'm gonna delete this app and I'm never gonna use it again, right? But how it could happen, right? Like how can we improve this experience for our users, and how can we make them trust our systems a little more, right? So essentially, you could say it is an orchid, but do you think we got it wrong? If you think so, like tell us what it is. And then you have a different type of relationship because you're admitting that you can make mistakes. I think this is a lot different from like what we used to do as programmers, like in traditional programming. Because when you have a bug, you try to like hide it, or you expect that people would not notice it, or you try to make it into a feature. But with AI, it's just so much better when you're upfront with your user and you tell them like, well, I may not be right. This is a nice way to work with a probabilistic paradigm. I may not be right. This may not be correct. So let me know if this is wrong. I can make mistakes, you know? And then this is very good because of two things. You can use it to tune your model. Like you will know things that are not doing so great, and you will end up finding incomplete data in your training data sets. Because what will happen usually is if you don't have enough examples of a given type of flower or plant or leaf or whatever, you will need to complement the data set to make the model more able to identify a broader spectrum of plants. So, and another thing is when you tell the user to help you and it lets you know that this is like an orchid and not really a daisy or whatever, the other way around, you will have someone that is labeling your information by hand and is an expert in that information. Because usually a person who's using that really has a lot of knowledge. And if he's telling you that this is not right, you like probably should believe them. It's kind of curating the data for you. And a lot of data scientists do not like the process of labeling data manually. But for every supervised model, this is so necessary. Like it's very necessary. And it's very important that we label our data sets and we have some kind of manual annotation. So you're getting annotation for free from your user, and you're really talking to him and letting him know like that it's not such a problem. You can make mistakes, and I'm going to learn from that. Like, it's a really long path, but I'm learning, and I'm gonna help you. And when I'm not right, you're gonna let me know. But you have more issues, right? More issues lie ahead because users, they try to push boundaries. So, for instance, this is a picture of the Google Assistant, right? And Amanda can teach you a lot about how to make your own conversations and apps, conversational apps with Google Assistant. But for instance, when you tell Google Assistant, "I love you," it will respond to you like in a very different ways. But in this instance, it tells you, "Oh, you're clearly pretty awe-inspiring yourself, right? And this is interesting because you do not create an assistant for people to tell it that they love it, or to try to have a, I don't know, a metaphysical conversation with it. But users push boundaries, and they test things just so they know how the system responds. And this is also an opportunity for you to build confidence with your user. For instance, like my dad, he got the same app, this one app where he used in the flowers, and he pointed it to his own dog, and he took a picture because he wanted to see what the system would say. And then imagine if the system would be like, that's a yellow rose, because I mean, it was not sure about anything, but a yellow rose got, I don't know, 20% match with this dog. So then it would be like, oh, that's a yellow rose. And people would be like, oh, my factory, this sucks. This is not great. But imagine if it says like, sorry, that's a tough one. Remember, we only recognize plants and leaves and trees. Now we have a wow factor. It's just like, wow, this is so nice. Like I tried to fool the system. I tried to cheat it. And it was able to understand that what I tried to do was not really what was intended. So I don't have to know that this is a dog, but I have to know that this is not one of the things that I should know what it is, you know, and I have to be upfront with that. So this is a way to treat these tests that users like to make with our systems. And it's an opportunity to build a relationship. And essentially, what we have to do, like when we work with AI, is to calibrate trust. We need to calibrate trust. And what does that mean? I have this example of a friend of ours. Amanda knows him as well. He's a GDE. I'm not going to say who he is just to preserve his identity. But he works for Tinder. And he has, I don't know who uses Tinder here. And I'm not even seeing, like, I can't even see if anyone's raising their hands or not. But he works for Tinder, and he has a lot of, I forget what it is. I think it's Tinder Gold. You can boost your profile, right? And you can like see who liked you and things like that. So then what he started doing is he started to make quick experiments with different pictures, changing the description and changing things like that. And he would boost his profile and see how many likes he got. And then based on that, he would optimize his profile. And one of the things he did was he was in doubt whether he should tell people that he works for Tinder or not. And he said, well, Bia is me. So he was like, I decided to do like an experiment and put that I worked in Tinder, put that I didn't work in Tinder, just leave it blank, and match with people. And I matched with a lot of people. I matched with more people than when I said that I worked for Tinder. But the thing is, when people knew that I worked for Tinder afterwards, like it wasn't there in my profile, they would sometimes think that I cheated the algorithm, that they didn't really match me, that I had some kind of advantage, and that I was hiding something. And usually, like, the conversation would not flow. And it wouldn't matter that I matched with the people, because in the end, they were very like, it was a really great distrust that they had for him. So then he said, well, so when I changed it and I put that I worked for Tinder in my profile, I got a lot less matches, but the matches I made were okay with that. Like, they were okay with me working for Tinder, or they knew that even though I worked for Tinder, I couldn't do anything to hack the algorithm. I don't even work with the matching algorithm. So he was like, it was much easier for me because I got less people, but people were really engaged. Like the girls that liked me were really engaged with that. So this is kind of like what we have to do with our AI systems. We have to be upfront with what we can't do, and we have to be upfront with our limitations. Because the people that come and use the system, they will be very aware of that, and it will be okay. And it's much harder than we have like a lot of people using it, and then a lot of people that are gonna ostracize us or give up on the system because they're not ready for it. So it's really nice to calibrate the trust and let people know what we can actually do. So finally, just like for us to conclude, because we're almost in the end of our time. So let's consider this as an example, right? People always ask me, oh, this app is so cool. Where can I download it? This is not a real app. The Pair team just created it to give examples of how a product that has AI embedded into it, and but also has human-centric considerations and very apparent, like would work or should work, right? So this is just an example. So suppose you download this running app, and the first thing that they tell you that you should do is to set expectations, which is something I've been talking about for a long time here, I think already. But the first thing you need to do is to set expectations. So for an example, imagine that I have this screen, music for your run, no playlist yet. You can be like, oh, I don't want to talk about that now, or I want to find songs. Of course, this is an exaggeration because they painted all the screen red, which for us, like Westerners, is usually a symbol of bad, is something bad that's happening in our system, right? Red is usually connected with a sense of errors or mistakes in our interfaces. But the thing is, like, suppose this type of interaction. You have music for your run, and then you explain what you do. Add 3 songs here, and we'll make a playlist for you. So now I can find songs, but I know what I have to do. Like here, I have no idea of what the system will do for me. But here, I tell people up front what they need to do and what I'm going to deliver, right? So I set the expectations. If they want to do that, they can do it. If they don't want to do it, they don't need to, but they know what I'm offering them. So this is the first thing, set expectations, and so people know what I'm offering them. The other thing is just say what you can't do, right? So I have here 2 examples. Consider this first case here. You're going to run, right? And imagine the system tells you night moves. Be careful on your evening run. And you're like, yeah, okay, this is very nice information. This is something very nice. Maybe it's a little dark, right? So let's go. Cool system. But then here is a little bit different because it says, be careful. It's after 6 p.m. and our run route recommendations don't include street light data. So now I actually know that the system's not taking that into account. Like it's not taking into account if I'm actually going to be able to see where I'm going, because it doesn't have that kind of information. So now I can make an informed decision of whether I want to reroute or I want to go anyway. Here, I'm just thinking it's being nice to me. And then in the end, if it sends me to a really dark alley, I'm going to be really, really pissed. But here is different because it's letting me know that it didn't have that kind of information. So you have to do a lot of UX research, just like you've always done to every other app and software, for people to understand like what is necessary and what are important informations that people would usually consider when making that type of decision, and that my system does not consider, right? And I have to do a really deep discovery to understand what I have to show and how can I tell people that I'm not using this type of information that they want to know. The other thing that I have to do is to explain predictions. So for me, this is very important. And this is why I thought that the Gamma system would be more trustworthy, right? I didn't count on breaking mental models. But for instance, imagine you sprained your ankle and then you're doing a recovery workout. And then it tells you, well, this workout is the best for ankles. This distance, this elevation, this duration. And the details are, we have adjusted your normal route to aid in your recovery. So you're like, yeah, you adjusted, but what really did you do, right? So I might be I might get very anxious because, okay, it made an adjustment, but I don't know what it took into consideration. Did it take into consideration like elevation, the type of terrain or whatever? Like I really need to know if I'm really going to be able to do it or if I should be doing it, right? So imagine that instead of that, they have this here. They have the same information, basic information on the route, but it lets you know that this is a recovery route because it has minimal elevation, it has an even surface, and we set a slow pace. So you're going to end that You're going to be like, you're going to take 15 minutes to finish it, but you're going to be able to do it very slowly. So you're still going to do it like that, but you're going to do it in a very slow pace. So this is what we are considering to give you a suggestion for a recovery workout, right? So it lets people take a closer peek in what you're doing. Another thing you should do or try to do is to prevent context errors. So for example, imagine you're here and you chose a running route, and the app would be like, you're in position for your next scheduled run. Enjoy your run. And run started. The run is already active. It's an intelligent system, so it knows you're there, and you don't have to press start for it to know that you're into the thing. But you're making that decision for the person, and it doesn't really make a lot of sense because it's something that the person itself, like, they should be able to tell the system when they want to start. Because suppose that, I don't know, I'm going to run, but before I want to eat a piece of cake. And I have this bakery that I really love that is like right there, and I'm going to eat a piece of cake and then I'm going to run. So I don't want it to start before I finish my cake. So then here is different because the system asks you in order to prevent context errors. So it asks you, it lets you know you're in position for the next scheduled run. Should I start a run timer? I mean, it is intelligent. It knows where you are. It knows you're in position, but it lets you tell them when you want to start, right? So the run is ready, but it's not active yet. So when you're making decisions for the user, it's really important that you at least give them an easier way out, right? Because here, for instance, like imagine you press OK, and then the run is active, and what you're going to do, like, are you going to, I don't know, quit the app and stop the process and then reopen? Will you still have the same run? Will you have lost that run? You don't know, right? But here, it's there. It knows you are engaged, and it lets you know when it really needs to start counting. And in the end, finally, is you have to show at least for a little bit of model confidence, right? So there are different ways of doing that. You have here by category, right? So you have different options that are considered best matches to your style. These are good matches to your style for some reason. Like if I look at that, I have an idea that this is a best match because it does not have a lot of elevation. At least that's what I consider when I look at that. And here it says, well, this match is unsure. I think this is so nice because you always have things that you do not know about the user. So you might offer them an opportunity to let you know if they are nice. Because if you look at that and you're like, I really like that run, I really want to do it. You can do it and like it, or maybe like you just choosing it will already feed the algorithm and let it know that you enjoy this type of run, right? But it's letting you know the information about you that it doesn't have in some way. Here is what we call the end best scenario, where you have a best route, but you also have other recommendations that might be really nice too. Because when you work with that and when you're working with probability, let's say a 90%, imagine Netflix, right? Netflix lets you know like, well, this movie is a 98% match with you. This movie is a 50% match with you. A 50 to a 90 is a lot of difference. But when you're doing like, well, this is the best route because it's 77% fit, and this is a 72% fit. It's not really different. So you will make a suggestion, but you will accept that people might want something else that are also very appropriate and nice for them. And finally, here you have like just an overall match number, which is what most of the algorithms that use AI do. But at least here it lets you know a little bit of what it's thinking, what it's considering. Like it's the explanation. So it lets you know that this is a good match because the most important things here we're taking into consideration is that it's an urban running. So maybe you like running in the city setting. And it's a mix of turns and straight paths, which is something probably the person here likes. So it's not only like the percentage, but also why that happened, right? So in the end, these are the 5 things you should have in mind when you're designing for AI products, which is set expectations, say upfront what you can't do, explain your predictions, prevent context errors, and show model confidence. So this covered a little bit of the mental model, explainability, and trust, and mainly the errors and graceful failure chapters. But we still have a lot of things for you to check out. So feel free to log on pair.withgoogle.com and read a little bit and leave your opinion on the feedback button. So thank you so much. I think we still have time for some questions. And Amanda, you can jump back in, I guess.
Hello.
Hi.
Here's one question. How could an app that asks for engagement training data work to filter out malicious bad entries?
I would like more information on that question. Engagement. What do you mean engagement data? And what would be a malicious entry?
So whilst Jonathan, if he's still here, adds more information, let's go to the second question from Joanna. Sorry if I pronounced your name incorrectly. Could you tell the 2 or 3 things that we should try to avoid during making Wireflow for our app?
The Wireflow is the wireframes, like the mockups you do for the app. Is that what you mean, Joanna? Well, I'm going to answer as if that's what you mean. If it's not, you can put it in the chat. But this is a very nice question because I don't think that people that work with AI are used to working with that type of instrument, of the type of artifact. So before saying 2 or 3 things that they should try to avoid, I'd be like, please try to do that before you start modeling, just so your user, you have a more clear understanding of what your user really needs. It's just like for those of us who work with products and design, we know that prototyping and wireframing and mocking up is something that is very necessary because it tangibilizes ideas and it tangibilizes things we want to do. And the thing is that with AI, people sometimes think that AI is very technical and something very new, something very is not something the user really interacts with directly. And this is very wrong. It's a very wrong idea. And this is the idea I'm more used with. I'm more used to in the industry. So I'm still having a lot of trouble trying to convince people that they should have a designer in their AI teams, that they should have a UX process in their AI team. So I wouldn't be concerned with things that you should try to avoid. I would primarily be concerned with, please do that and respect the design process and try to understand what is really necessary for you to factor in the model, because this is the time where you're going to know what are the really important features. It's not only what you think are important, but like what people are really telling you that is important.
Great. So we have some comments here. This was really enlightening. Thank you very much, Bianca. Great presentation.
Thanks, Sam. Thanks.
I think the context of that question would be something similar to what happened in Zoe. And then Jonathan from the previous question added, adding loads of puppy flowers. And then Sam added, bad actors trained Microsoft's chatbot to say really nasty stuff.
I remember Tay's case of Microsoft. What we usually do is we do an outlier detection analysis. We like these are different problems. Like the problem of because the problem that Jonathan is it his name? Okay, the problem that Jonathan is bringing is that I'm purposely training the system wrong. I'm feeding wrong information. It's wrong information because it's out of my scope. It's out of my domain, like of my area of knowledge. So what I do in this case is try to do an outlier detection system, because then when there's something very, very different, it would be able to flag that I maybe shouldn't use that information to train and to validate my models. This is what people do usually, like when they're doing a fraud, credit card fraud models, right? You have a normal type of behavior, you have a normal type of entry that you're making, and then in the end, well, there's something that is off, and this is like the main product of this type of model. But you can also use it to filter the data that you're feeding your system. So you can have a model that is not your primary deliverable, but that helps you curate the data that you're going to use to train the model. So in that case, I would use an outlier detection model. But in the case that Sam's talking about, this is much more tricky, because it's not wrong that, how can I say that, like in a way that doesn't sound awful, but it's like, it's not wrong that the information that was getting there to Ty, the chatbot, was not wrong, but it's something that, like, common sense says that has a lot of problems with it, and it's something that the artificial system, the artificial intelligence system, is not able to tell by itself. So you would probably have to flag some word clouds. What we do in these cases, I don't know how to explain that is particularly well in English, but what you can do is try to make semantic clouds, like try to understand if a word has a positive or negative connotation, and try to understand what types of words that are related to that, and what if they represent something bad or something good in the context. And then you also let the system know. You either remove that from training, or you tell the system that it should not look at those examples, but you would have to make a pre-filter too. But I think that, like, the case with Ty, I think the most important thing for us to understand, thanks Joanna, but I think the most important thing to understand with Ty is that Microsoft thought that the internet was a safe sandbox. Like, it was a sandbox that it could send out a chatbot and it would be okay. And the internet is not a sandbox. So you cannot rely on people to just feed good things to your model. You have to curate the data that you're using. And I think I cannot ever stress that enough, the importance of curating data. So I like that Jonathan's question really, I think, in the end, went into that direction of how important it is to curate your data, to validate your data, to just is not everything that you receive, is not everything that you can put out there that you should put out there, and is not everything that you receive that is really useful. So for instance, like in my company, we have 35 million applications. In the year of 2020, we had 35 million applications for job employment. And a lot of CVs were processed, but we only use 11.5 million for training, due to a lot of different reasons that I can't really explain why here in detail. But like, we don't use every single application because there are things that we find prejudicial to the model. One case that is very typical is like, well, you have a lot of people that are very, very compatible with the job opening, but then in the end, who gets hired is someone who was indicated and is not really a fit, like is not really a good match to the job opening. So we do not train our model with those cases, because we would be teaching the model that experiences, information, and certifications are not important. What is important is only the pure fact of being indicated. So we need to curate and we need to remove those cases just so we don't teach our model poorly. So yeah.
Excellent. Thank you, Bianca. Wow, you took all the questions. Thank you so much for being here. And now we're going to reward ourselves with dinner. And if you'd like to talk to Bianca, I think you can go back in the slide a little bit. She's shared the slide with her social media. So her name is Bianca Ximenes. Feel free to go and follow her everywhere. Everyone, have a lovely time of the day wherever you are, and we'll see you soon.
Cool. Thanks, everyone. Thanks, Amanda, for the invitation. Hope to see you soon. Bye
See you
bye.
soon.